Hi everyone, yeah, I'm Perk. I came from Poland and I work at Canonical now, but for the past almost 4 years, I worked at SumoLogic, and this is a presentation about the journey towards OpenTelemetry Collector from the vendor perspective. So I hope that it will help you actually understand what is going on with this OpenTelemetry, why is it so successful, how can it help you, and how it helps vendors actually to do their stuff that is interesting for them. So let's start with this information that, you know, when you try out, when you go there and look for an agent, you end up with this collector zoo, right? You think, okay, I just want a collector. And then there's like many collectors with many different configuration options, with documentation in different places, and so on and so forth. It's actually quite hard, right? And we had this problem as well, like, okay, what do we support? Do we support all of them? Nah, that doesn't work really well. So, because we support also Kubernetes, maybe let's support only those that works on Kubernetes. And that doesn't work as well. It doesn't work either because on Kubernetes you can end up with many different things. That would be very actually weird if you just ended up with this kind of stack. And we thought, okay, that is not so great. That is too much overhead for us. Let's just try to focus on the OpenTelemetry. And this is the journey that I'm actually talking about. Where it all started. It started on Kubernetes with those de facto standards because, in 2019, when we were choosing the agents to work with, we thought, okay, what is everybody else using? And everybody else is just using different agents. Like that was in 2019. So for logs, it wouldn't be really weird if you ended up with Fluentd or Fluent Bit. And for Fluentd, it's great, right? It's a lot of plugins. There's a community. There is a documentation. But it is written in Ruby, and with that, it does the job. Maybe it's just a little bit odd, but well, okay, it works, right? Then we have the Fluent Bit. Fluent Bit is awesome, right? It's crazy fast, great memory usage, and it's written in C. And that doesn't really work with the vendor that doesn't have this backend in C because you don't have that much knowledge within the company, right? So it is really hard actually to be on top of the things, on top of the bugs, on top of the security features there. And for metrics, like everybody uses Prometheus, that is still the case, but not from the vendor's perspective, because even though this, the community is big and the documentation is there, the memory usage is like, okay, it's a database, it needs some memory. It is a database. And vendors like Sumo or other are database in the cloud, right? Most of the time, or on your local infrastructure. Prometheus is not a forwarder. It was not a forwarder back at the time. Right now, I know that this is a Prometheus agent, so you can forward your metrics. But its main use case is to just store those metrics internally and then show you those, right? And we didn't have traces at the time. We were introducing those, and because we were introducing those, we thought, okay, what do we do here with tracing? And thankfully, OpenTelemetry just came out to be, actually, at that point. And we thought, okay, this is very, very interesting project. Let's try out with that. And why? Why do that? Because OpenTelemetry is not a de facto standard, right? It provides the libraries for your applications. It provides the agent, right? Doesn't give you the backend. And that is actually a very good thing because, if you think about it, there are many, many companies that provide you with the backend. So you have this project that helps those other companies, right? And at the same time, does not compete with them. So everybody can be actually compatible with the OpenTelemetry project and do their own thing, do the thing that they're actually the best at, right? To give you the greatest experience you can get from the bucket itself. And we have this specification for OpenTelemetry, which means that it is well thought through. We have those languages, those SDKs for languages. You just want to write something right in your application. You have many, many different languages actually out there, and you have libraries that are consistent. So for logs and for metrics, you just use the same thing, not two separate things. That is great, right? And then the collector. Thankfully, I don't have to talk about the collector internals as much because actually that was covered just before me and an hour ago. But I want to tell you one thing because You know, remember when I said at the beginning that you ended up with the collector zoo? That is just a little bit the case with the auto collector distros as well, because you have the core distribution. Okay, core distribution means just core components, but there are not so many of them. And if your use case is very limited, it might work for you. But if your use case is like, I have Kafka and I have logs that are like locally stored and I have like Redis, those are not there. Like Kafka is there, but the local files are not there. So core distribution might be usable for you, but it might not at the same time. Then you have contrib. Contrib is like all the way around, right? In contrib, you have everything. The problem being that OpenTelemetry says that, hey, you should not use contrib because we do not take responsibility for the stuff that it is there. Vendors do, right? They add their components, they keep up with the stuff. It might not work. So what do, right? Thankfully, you have the vendors' distributions, like Grafana agent, for example, or Sumo Logic agent, or ADOT. What they do is that they take pieces from the contrib, stick them up together, build their own distributions, and just give that to their users. And you can actually do this, do it yourself as well, because it's actually very, very easy to build yourself an OpenTelemetry distribution. So on Kubernetes, you have this use case like, okay, I want to take logs, metrics, traces, and I need to enrich all of those with metadata and then put those on the backend, right? How we did that historically. So we started with traces in 2020, just around that, and I thought like, okay, we can try out OpenTelemetry. We didn't have any much pushback because that was a new thing. Traces were new things, so it was actually quite easy to convince everyone like, hey, it's a safe bet. And it was, actually, it worked pretty well for tracing at the time because OpenTelemetry, you know, it emerged from those two tracing projects. So traces are like the first class citizen from the get-go, and also it is the most, the best supported signal type at this moment, actually. What we found pretty easily that with tracing, you get like a lot of data. Like huge amount of data. That is not the problem with OpenTelemetry itself because that just traces, right? There's a lot of them, and there is like no easy answer how to tame this flow, because if you wanna, for example, like you can sample, obviously, but if you wanna filter, you need to get all those spans that create the trace, and to get all the spans, you need huge memory to keep all those, so there are like no easy answers here, but vendors are working on that. Like they say, hey, send me all of your data, I can filter them out for you. Then we thought, okay, this works pretty well for the traces. Let's look at the metadata layer, okay? And on metadata, we had Fluentd at this time. The problem being, like I said previously, is this performance because it is single-threaded. So when we switched to OpenTelemetry, we found out that the best single thing for us was that we actually did not have the back pressure on the Prometheus. We use Prometheus as a forwarder. Prometheus has this feature called remote write. When you back pressure So when you back pressure the remote write, the Prometheus memory just goes out of the roof. It's like enormous. And when we switch to OpenTelemetry Collector, because it is so much more performant, it has the Golang performance, so it's pretty good. We did not have this problem anymore. So that was really, really actually good for us. What we saw. So now you can see the Fluentd of across the cluster. There's like a couple hundred of nodes. We used on average like 38 CPUs. We went down to 13. It's the same load, the same cluster, the same nodes, right? So 3 times. Great. For the memory, 220 gigabytes of RAM to 75 gigabytes. But that was the beginning because after some tweaking, we got even further, 11, 20 times less, right? That's huge, actually. And for the instances, 85 for Fluentd and 20 for OTC. Again, some changes, and we went down to 11, which is 8 times less, which means 8 times less we need to go and ask API server, hey, what is my metadata? What is my metadata? What is my metadata? If you do that, you kill your API server, you kill your Kubernetes cluster. That is not good. So we were happy with that outcome, like very, very happy. So, we had the traces covered, metadata covered. Let's look about logs. And for logs, we had Fluent Bit, which is actually good, right? Like it has great CPU user, like great memory, hard debug issues, but that's the thing, unfortunately. It didn't support metrics and traces at the time. It does now, so that you know. So you might end up in a different place, actually, if you are to look right now. But for us, we're already sold on the OpenTelemetry idea, so we switched. And we found that actually it works quite okay. The CPU usage is great. Memory usage is reasonable. You will never get to the Fluent Bit levels, right? But the important thing is that no major feature was missing. Along the road, we found some feature missing. When then Sumo worked with customers to add those, and they are there already. But at this point, I think that for the average use case, you are good. So last but not least, we had almost all of the stuff already transferred. We thought, okay, it's time for metrics. Metrics happened in September, so that's like a very fresh thing for us. But yesterday I talked to Christian that had this talk at 9, and he said that they did this actually a year ago, which was brave. And when we switched for OpenTelemetry, what we saw is that we get a very, very small resource usage because, mind again, we did not use Prometheus as a database. We used it as a data forwarder. And you get this very, very nice thing called Prometheus Receiver that is currently in beta. This is a drop-in replacement. It literally reuses the libraries that are there from the Prometheus inside OpenTelemetry. And for the configuration is almost the same. Like it supports whatever makes sense in the OpenTelemetry world. And you can almost use it as is, which is very, very nice. And graphs-wise, again, CPU for the Prometheus across the clusters went down 5 times, and the same story for the memory. It went 5 times as well for us. So yeah, we are happy. Right now, we switched our stack from this one to OpenTelemetry one. And it's great. Now you have OpenTelemetry, all the way down almost, and you don't have the backend. You can send that to backend or actually to backends, right? Because it doesn't really matter. All of those, many others, support OpenTelemetry right now. So you're not tied in to the vendor that much anymore. Were there any issues? Yes, they were. They were funny at times. Like, for example, let me tell you about this one when in the file log receiver, this piece that takes the local log files, depending on when you had an empty line in your log file, you either ended up with no file being read, file being read twice, or file being read in a loop. But that was 2022. Those bugs are not there anymore. The state as of now is much, much better. Those components that are mostly used are in a very good shape, I would say. And you obviously get different results if you use components that are like fresh, new, or the support from the vendor or from the community is not that great. But the average use case, I would say, is actually very nice. That being said, I hope that helped you actually, to get hooked on the OpenTelemetry. If you are brave enough, please try it out. If you have any questions, I'm here to answer. Thank you.